Hello, everybody. Welcome to today's webinar on understanding DataOps and its impact on application quality. My name is Chris Riley. I will be moderating today, and we are joined by George Demarest of Unravel, and he is going to explain to us the power of DataOps in modern applications and application quality. This webinar is hosted by devops.com and the content is brought to you by Unravel. And before we begin, I'm just going to talk about a few logistical things. You can hear us, but we can't hear you. So if you have a question, type it into the question dialog in the GoToWebinar box there, and we will get to those at the Q&A section at the end of the webinar. The other thing that's going to happen at the end of the webinar, right after the Q&A, is we have a giveaway for 3 $50 Amazon gift cards. So please hang out all the way to the end to find out if you're one of the winners. And if you are, we will notify you after the webinar is over how to obtain that. And finally, this webinar is recorded. So make sure you share it with your peers because the quality or the content is actually awesome. So is the quality. We're talking about quality. And make sure you share it with your peers and you can have that to view at your leisure after the webinar. So I'm really excited about today's topic. It was really the folks at Unravel that opened my eyes to one of the challenges and one of the things that's happening in the modern application world, which is when we talk about application delivery, we talk a lot about monitoring, but usually we talk about it in the context of infrastructure only or the front end only. But when you think about it, your application backend, where your data is it poses a new set of challenges and sometimes much more critical and new challenges with regards to remediation. Remediation very often takes longer because there's different things that you have to address. And this is your data. This is your most critical part of your application. Front ends are somewhat trivial when it comes to thinking about the data that actually drives your applications and your users obviously need access to. So that's why we're going to talk today and learn about what DataOps is and how it differs in the modern application delivery world and how it relates directly to application quality. So George, with that, I'm going to turn it over to you and you can tell us all about DataOps.
Thanks. Thanks, Chris. And thank you, everyone, for joining. Thank you for DevOps for inviting us. And so when we talk about DataOps and application quality, we're not talking about traditional Java applications running on a large server. We're talking about the new era platform of data applications. In fact, Gartner has been talking about DataOps for a few years, and they've even have stopped using the word big data. They don't find it to be too relevant anymore. It's kind of has too many meanings, but that's really the space that we're talking about when we talk about DataOps. So let's talk about this. So these types of applications, what we call data applications or modern data applications or big data applications, whatever you like, is rapidly maturing, but still has a lot of a long ways to go before it is really a bulletproof, easy environment to manage and an easy environment to write applications for. And so the chance to introduce human error and really all sorts of errors is very high. If we look at this generalized Swiss cheese model, I'm not making this up. The Swiss cheese model is used for risk analysis and management and used in security and aviation to prove a point really that there are different levels of behavior of organization that impact application quality. At the highest level, your organization may introduce the possibility of failures. The supervision of the data team might not be mature, which might create an environment where it's easy to do something wrong, and then the error is the culmination of all of these holes in an organization to create an unwanted incident. If we look at data applications, the organizational challenge might be, well, we don't really need a chief data officer or a chief analytics officer. It's really just, a tiger team or what have you with big data or data applications. Second level might be that IT management views big data as experimental, and the data team, go ahead, go do whatever you like, govern yourself. And that creates an environment where the preconditions exist for some bad activities. So sure, let's give our developers the ability to allocate as much memory resources or CPUs or number of nodes. And then, of course, the fully empowered developer, then I need maximum memory for all my jobs. I'm the power user. I am the alpha developer, so I need maximum memory. And boom, one of the classic problems of especially Spark applications is an out of memory condition. So boom, your applications fail, maybe your cluster fails, maybe your whole program screeches to a halt. This is what can occur in an environment that is maturing. So if we, oh, there we go. So in walks DataOps. DataOps is a thing I mentioned. Gartner has been talking about this. There's a blog from Nick Huttaker, who many of you may know. DevOps.com itself has 33 articles on DataOps. There's a DataOps group on LinkedIn and so forth. It is a thing. But the point that Nick Huttaker makes in his blog is that you cannot buy DataOps. You build DataOps. You have an intention to create data ops workflows, management hierarchy within IT and the business and so forth. So it is like a data pipeline. You don't buy it off the shelf. You build it, you create it. And of course, in the modern world, if you don't have a manifesto, you're not anywhere. So there is a data ops manifesto that you can check out. I've just included it for you to look at. Pretty interesting. But here is the definition from the Gartner glossary, that DataOps is a collaborative data management practice focused on improving communication, integration, and automation of data flows between data managers and consumers across an organization. The goal is to predictably deliver change management of data models, and related artifacts. So DataOps is people, but it also uses technology and a lot of automation. And this is a key point that I hope, if nothing else comes out of this presentation, that really data quality, application quality in the big data or the modern data world really requires a high level of intelligence and a high level of automation for it to actually work. With clusters that can have thousands of nodes running hundreds of applications, full time for weeks, months, years at a time. If it's all done manually, it really just doesn't work. And many of our customers are discovering this. So the question is, are we going to be swamped by this complexity? Because there's complexity at many different levels in a distributed processing environment. You have the application logic itself, which you don't see as many huge monolithic applications, but that doesn't mean that the logic isn't complex, and the use of distributed computing techniques makes it complex. The creation of data models with an ML or AI environments can be very sophisticated and very complex. The format of the data, how it's stored, how it's ingested, how it's retrieved, and how it's used is complicated. And then the underlying software stack and the data pipelines that companies are building are complex themselves. You have an ingest process. This is kind of a classic big data flow diagram that shows you how data progresses through the data stack. So you have data ingest, you have data prep and data quality, you have batch and real-time processing to do all sorts of, to do ML or AI or predictive analytics, and the various types of use cases like fraud detection and recommendation engines, and all these modern algorithms that are that rely on this very powerful but complex distributed stack. You have the results store, and then the delivery of the results to the data consumers and reports or dashboards or alerts or so forth. So multiple layers of complexity makes any application or cluster environment difficult to tune, to troubleshoot, to make production quality, and to scale to cloud scale. And as I said, so only intelligence and automation can win in an environment where there is so much complexity. And that, of course, ultimately affects application quality. And managing these applications is really difficult and expensive. It's hard to identify a root cause because of all the moving parts. So my application failed. What does that actually mean? Did the Spark stack fail? Was there a bad driver installed? Was it application code? Is the queue overrun with jobs? Is the whole cluster memory challenged because of a rogue application? Why am I missing my SLAs and my data pipeline? It's a complicated question. Or if you're in the cloud and doing your big data program in the cloud, all of a sudden my cloud bill is like way out of control. What is causing this? And then of course the developer is not the code, no, it's the cluster. And then the ops people, it's not the cluster. This rogue developer created a Frankenstein application. And to borrow a word from the security area, there's a lot of things that can go wrong. So a large kind of attack surface of bad news for a big data application. So if you incorrectly size a container, if you have the wrong file or data formats, if your machines are going down or failing, if it's incorrectly scheduled, if the network is not configured, if the data layout is incorrect, if there are bugs in the code, etc. There's a lot of things that can go wrong. So once again, it's intelligence and automation that are going to kind of be the payoff for this. So that really means that DataOps needs a lot of help, and more of the analytics kind of I won't say ironically, but coincidentally, the type of applications that run on big data platforms are the types of applications that are probably going to help your data applications run with better quality and better performance. Because without intelligence, without automation and AI, you have lots of different log data from different systems. You have lots of different administrative interfaces. There is a Spark console, there's a Hadoop console, there's command line stuff you can do. There are, each of the Hadoop farm animals that you must deal with, they all have their own interfaces. So debugging becomes manual and difficult and, demoralizing, quite frankly, where there's multiple tools, you don't really get a complete view, and you don't really have context or intelligence. So that's why if you apply intelligence and automation to the problem, as Unravel has, you get to the point where a lot of enterprise IT people basically expect that you have a complete view, that you have a high fidelity correlated view of what's going on in your big data environment, and that a lot of it is automated. That's how ultimately application quality will reach the levels where you can set and trust the SLAs that you're used to setting for any other enterprise technology. So and that's where Unravel comes in. I'm going to talk just a little bit about Unravel and talk about how we approach the problem. But once again, without AI and without Unravel, you have multiple tools. You have manual data and log collection. So, machine logs, application logs, error logs, etc. Um, you have a fragmented view with multiple consoles. You get minimal intelligence. You get no contextual intelligence. The Spark console doesn't know what Hadoop is doing, and Kafka console doesn't know what Spark is doing, and so forth. So, and then uh, if you want to tune or troubleshoot this environment, it's very thorny, very difficult. And then if you want to know what everything costs, it's really difficult and not what an IT manager or a CFO is going to want to see from the IT department. So what we do at Unravel and what many AIOps companies, kind of a new category, AI-driven IT ops technology, what it does is it provides, in this case, a single unified full stack cross-platform console with a complete correlated view of what's going on. I'll show you, I'm going to give a very brief demo at the end. Um, Unravel does all of the data and log collection automatically. You don't have to deal with it, and we use very lightweight sensors rather than heavyweight demons running on all your cluster nodes. So very light touch on the cluster to collect all the data that we need, and we continuously collect it. So Unravel is a learning system, is that as the system runs, it learns more, and we update the algorithms, we improve the models as we go along, and I'll show you how that works. So we have built-in intelligence, built-in AI and machine learning, but also less glamorous analytics, just rules engines and lookup tables and just whatever works. There's no one size fits all for the intelligence that we use. We use the best tool for the purpose. Um, and from that AI and ML and all those other analytic approaches, we provide contextualized recommendations and insights about what's going on, and even automatic remediation of problems. And I'll show you what that looks like in a moment. And comprehensive chargeback or showback reporting to know, really at a deep level and a detailed level, who's using the cluster, which users or departments are using more than their share of cluster resources, how much it will cost in a cloud environment, because remember, when you're running data apps in the cloud, it is all expense, it is all your cloud expense. So people are watching their cloud bills and want to know for sure that they're getting every last ounce value out of the computing and storage that they're paying for. And that means application quality, as in the reliability, the performance, the predictability is crucial in big data environments. And this is the problem that Unravel has set out to solve. So where is the value for data ops created? Well, the business value is that basically your new applications, many of these, strategic or revenue generating applications, you can run more of them, you can run them faster, you can put them into production more quickly, you can evolve them more quickly when when you have the type of insights that can be provided with a platform like Unravel. Better performance is really its own gift, but once again, for governance and IT, you want to be able to set and meet SLAs. So that is a real value. Getting maximum getting at maximum throughput from your storage and from your compute clusters is done. We optimize the entire cluster as well as individual jobs and workflows and data pipelines. So faster completion times, better quality, fewer failed jobs, better efficiency. As you'll see, Unravel can provide very precise recommendations for what you should set your container sizes for, your allocated memory, your storage memory for Spark, and so forth. And that being able to right size the cluster resources for your exact, tailor it to your application, and Unravel can get very granular and very smart about this. That kind of efficiency also means you can run more apps faster, get them into production faster, and so forth. And then just your data teams themselves are more productive because we provide these recommendations, which are, by the way, in plain English, and also I mentioned very precise insights into what's going on in your cluster. So with the automation that we provide on top of that, DataOps and AIOps and DevOps teams can be a lot more productive and worry a lot less about human error. So technologically, how does this actually work? How do we do this? And it's an interesting. If you look at the diagram on the right, we've had monitoring tools, and monitoring tools are essential and great, but they get to the point where they can, sort of acquire status and show you a lot of detail, provide some analysis, but typically do not allow you to act and change your environment so that it runs faster. It gives you some clues, but an AIOps platform like Unravel actually provides deep analytics and the ability to automate much of the tuning and troubleshooting required to raise application quality. So data collection and correlation is a key part of it, that you need to collect data from all the cluster nodes, from Spark, from Hadoop, from all of the processing components of your data stack. So collecting all that relevant data, whether it's log data or status data, or application logs or configuration data, and then correlating that data. It's not enough just to have a big pile of status data. You need to correlate that data using advanced intelligence, and you need metadata about the environment so that the system can know what the operating parameters are to make the system better, faster, more stable, etc. So as I said before, this is becoming very much like a big data application. We have created an operational data model using all this data that is about informing monitoring, troubleshooting, tuning, and management using this data model. And it's really similar to a CMDB, but it's a lot richer, it's more powerful, and it evolves over time. We both evolve the algorithm, as I mentioned, but also it learns as it gets more data about your applications. And then the analytics on top of that is really where the rubber meets the road, or at least where the road is created. So basic and advanced statistical analysis is required, so you can correlate, classify, extrapolate from the metadata we've collected, predictive analytics for forecasting, capacity planning, and planning for growth. The ability to recognize patterns and anomalies, which are classic big data problems, and being able to do root cause analysis, as I'll show you in a moment, and then be able to prescribe and recommend through an inference engine, and provide the context, the information topology to make it all make sense, and the coded expertise of the people that know Spark. So Unravel is chock full of experts on Kafka, on Hadoop, on Spark, and how all these systems interact. So coding that expertise into the platform is part of the AI approach, and part of what Unravel has been doing. And then to actually take action, automation of providing the automation to be able to do something about the problems you encounter. So auto tuning is one of the applications, or one of the use cases of Unravel. Autonomous resource allocation and optimization. Are you over provisioning or under provisioning memory or CPU or storage. All of these things can be automatically tuned and optimized with Unravel. Doing load balancing and job scheduling, moving jobs from queue to queue automatically, also a capability of Unravel, and then providing what we call auto actions or automatic responses to alerts, or when someone trips over a performance threshold or an SLA threshold in order to recover from failures. So this is how we viewed the problem of approaching data ops and data and application quality using the very tools that these platforms were built to run. So it's really quite an interesting kind of snake eating its tail sort of a scenario. All right. Some of the use cases for these types of platforms. So I'll show you in a moment how we've approached automated root cause analysis of application failures. Automatic workload management, so making sure that jobs are distributed across the cluster correctly, that you can eliminate contention for CPU and for memory and for IO, and correctly size your containers and your VMs and your cloud server instances, and putting the VMs on the best cluster nodes or the best queue. Then there's kind of a classic APM where you are, basically doing analysis of a running application and getting recommendations and insights to tune the environment, to change tunable parameters and configuration settings. And then finally, kind of beyond the scope of this presentation, but there's a lot to do with the cloud, and Unravel is heavily into optimizing data applications in cloud environments, and that involves right-sizing your cloud server images, choosing the right configuration, the right pricing scheme, the right pricing promotion might be available to you, or you might be getting a deal from the cloud provider. So Unravel can do a lot of that as well. So just to show you the product architecture, I've talked about most of this already, but on the left side here, the modern applications, whether it's AI, IoT, machine learning, or predictive analytics, we collect data from the platforms themselves or the technologies: Spark, Kafka, Hadoop, NoSQL databases, SQL engines, massively parallel databases, and direct access through application APIs, and we also monitor and collect data about the infrastructure itself, whether it's cloud or on-premise or hybrid environments. We collect that data, we create that data model, that correlated dynamic data model that I spoke about, and then we use one of several analytics or processing engines. We have an analytics engine, an automation engine, a tuning engine, and an inference engine, and then the outputs of that are the Unravel dashboards or custom reports or automated actions that I spoke about, or smart alerting, sending a page to you, PagerDuty, or a Slack message, or an email, or a text, or we do reporting on numerous aspects of the running environment, and we provide recommendations. And I'm going to show you what that looks like in a moment. Okay, so let's take one example, and that is root cause analysis. So, there was a survey by App Dynamics recently that said that most enterprise IT teams first discover that an app has failed when users call or email their help desk, or someone posts something on social media, which is a rude awakening for any IT team. So we want to avoid that. And the problem is with these complex data pipelines and multi-phase applications, that you might have to deal with 5 levels of stack traces in this particular form alone. So our approach I talked about that data collection and the building of our data model. That is to get the log data and the configuration data out of the data silos, out of their silos, and into our data model. And then we apply algorithms to analyze this data, and then whenever possible, we take automatic action. But and we provide some automatic fixes that I've mentioned. But the use of AI and automation is really what differentiates us and provides a lot of value. So if we take root cause analysis, for example, manually determining the root cause of an app failure is really time consuming and often requires deep domain expertise and can take days or even weeks. But with Unravel, using AI and our inference engine, we can do root cause analysis in a matter of seconds. And let me show you how that is. So the challenge, many correlated stack traces and difficulty in root cause analysis. With Unravel, we detect the failures, and we can drill down, as I'll show you in the tool in a moment, but we'll also come up with the events that caused the failure and provide a recommendation as to how you can remediate that problem. So once again, reducing troubleshooting time from days to seconds, and helping data scientists and analysts be a lot more productive. And the way we actually do it is we draw on a large set of root cause patterns that we've learned from customer environments and partners and our own testing, and we constantly update this collection of root cause patterns. We then continuously inject this root cause data to train and test our models for root cause prediction and proactive remediation. So it does require that we inject this learning, the expertise from the experts, but also our collection of learnings from other failures, so that we build this predictive model. If this application behaves this way, there's a 99% chance, for instance, that it is an out-of-memory condition caused by this parameter being set incorrectly. And a lot of this is mundane, stuff that you just be pouring through, tons and tons of data. It's a grueling, demoralizing process, quite honestly. So applying this type of approach makes it a lot more elegant, and this is what Unravel looks like, but I'm going to change to actually my demo screen and show you what Unravel looks like. Never mind a lot of the detail here. I know it's going to be difficult to see, but at the very top level, you'll see that Unravel is organized between an operations context and application context, and we provide a set of reporting that is very valuable. So you can see high-level high-level metrics. At the bottom, you see a list of inefficient applications, whether they're Hive or MapReduce or Spark or Impala, and that even shows you which are the most likely issues causing that efficiency. But let's move on, go to the application list. So it may be difficult to see, but this Unravel supports all these different application types, so Hive, Impala, MapReduce, Pig, Spark, Tez, future coming Athena, and others. So we will continue to add additional application types and platforms. You can sort and filter by status, so succeeded or failed or killed or running. You can also filter by the department or the project or an individual user or an individual queue or an individual cluster, and lots of other things. So you can see the application name, its start time, its duration, how much data it reads and writes, and so forth. I'm going to go from there directly to a Spark application. This actually succeeded, but Unravel still has 3 recommendations. As you see this orange bar across the top, Unravel has 3 recommendations to improve apps efficiency. So this isn't root cause analysis. This is just application tuning. Let's see what these events are. Well, actually, first, let me show you that. So this application had 4 stages to it. You can see a Gantt chart of the application execution. So one stage took a lot longer than the others, as you can see. You can see errors. There were no errors, but let me show you. This is an interesting screen that shows you the configuration parameters that are relevant to this run, and there are 1,030 of them. So imagine, wading your way through all of that stuff. We also provide some filters so you can just see memory parameters or resource parameters and so forth. But let's look at the events that Unravel has discovered. Well, it gives us some clues about some configuration parameters that could be better tuned. So you can see that the current value of this of Spark default parallelism is 2, whereas Unravel suggests that it should be 89. The executor memory looks like it's over provisioned. The Yarn executor memory overhead probably does not need to be as high as it is. So Unravel gives you pretty precise recommendations. Oh, and guess what? I can then just auto tune, and this brings us into our I'm not going to create a session, but I'll show you what a session looks like. So you can go and make numerous application runs and look at, and these lines show performance in different runs and their how it changes over time. So you can get pretty granular with auto tuning and set it up very easily. So if we go back to our application view, I'm going to actually single out Spark applications, and I'm going to look for failed applications. So let's see. Well, here is a failed application of a real-time sentiment analysis, and see what it looks like. Okay, so here's it failed, and here's the failure. And you can see now, this is in plain English, there's low utilization of a Spark storage memory, and gives you actually plain English recommendations as to how to deal with that. So root cause analysis really is a question of drilling down further into the Spark application and seeing the recommendations and insights that Unravel provides, and then taking appropriate action or set automatic actions yourself, and that is done in another screen. I'm not going to show you, but I think I'm gonna stop there with the demo and finish up my presentation. So let's just review. Without AI or without a tool like Unravel, there's multiple tools, manual data and log collection. There's a fragmented view of what's really going on. You don't get really good intelligence, and troubleshooting is manual, and tuning is manual, and error prone, and trial and error. And you've got to basically fire up a spreadsheet and try to figure out what everything costs. So with a sophisticated tool like Unravel, you have a full stack coverage, cross-platform, in the cloud, on-premise or hybrid cloud. We have a single complete correlated view relying on the Unravel dynamic data model. Automatic lightweight data collection and log collection from the systems using lightweight microsensors. We have the built-in analytics that powers recommendations, insights, and even automatic remediation, and then full chargeback and showback reporting. I probably should have showed you that. It's pretty cool. Actually, I can show you. Let me show you. It's pretty good. Operations. Oh, no, I'm sorry. It's reporting. Let's see, chargeback. So here you see chargeback. You can actually add additional filters and filter it by user, and you can drill down further into specific applications and specific users and so forth. So pretty useful. And then you can provide some pricing data here to know what you're spending with your cloud instances and so forth. So that's the Unravel approach. And kind of what makes us different is the full stack coverage, the use of AI and advanced analytics, um, fully extensible for running in the cloud or in hybrid clouds, um, and does automatic tuning and remediation, not just monitoring. And it is not just a management console, it is an intelligent agent or intelligent platform that interrogates the entire uh, big data stack and the running applications and data pipelines that are using that stack. And together, we we work to provide the highest application quality for DevOps teams. So this really is a a data ops team, and this really is a data ops platform that I think people are going to really find useful for their data environments. So Chris, that brings me to the end of my
Great.
prepared remarks. Do you have any questions or comments?
Yeah, actually, we've gotten some questions from the audience, and I'd like to go over those. I'm just going to remind everybody, if you do have a question, just type it into the webinar dialogue. If we don't happen to get to your question, the folks at Unravel will receive them, and they can respond back to you with answers to those. Also, remember, right after Q&A, I'm going to announce the 3 winners for the $50 Amazon gift cards. So make sure you stick around with that for that. Yeah, George, one of the questions and one of the things that I think comes up as you introduce this concept of data ops and the importance, especially in big data applications. But the question is, how does this relate to the pure APM world? So how is Unravel like a tool like AppD or New Relic?
Well, it does a lot of the same things. The major difference, and by the way, the one of our investors is from AppD, so they understand the value that we're bringing. It's because the platform is so different. Basically distributed, clustered processing, which means it could be on hundreds or thousands of servers or containers or VMs, what have you. So we do a lot of the same things, but the problem space is a lot different, of course. For one thing, there most of the modern data stack or the big data stack, whatever you want to call it, is based on open source projects that no one really controls. So it is a difficult environment to track, and we, Unravel sprints, stays at a sprint to keep as up to date as we possibly can, constantly, supporting new versions, not only of Spark and of Hadoop, but also of Amazon EMR and Microsoft Azure and Google Cloud Platform. So it's a big job, something that really can't just be bolted on to a traditional APM environment. I mean, some of the APM vendors like New Relic and AppD, you know, do the beginnings of what we do, but we have been focused on this now for 5+ years. And we can attest to how difficult it is, but there seems to be a dire need for it.
Yeah. So I think that leads well into the next question regarding AI. AI is a fairly loaded term and been used in a lot of contexts. And one of the differentiators in the data ops and what you guys provide, as you mentioned, is the learning and the AI. Is AI the best analytical approach for application quality and performance management?
Yeah, that's a good question, and we are very careful not to AI wash everything, but there's actual and real AI in the product, and our CTO is a very bright fellow, so he is introducing, as I mentioned before, um, the right. Uh, the right analytical approach to solving individual problems. So sometimes AI is the right thing. So when you're building that root cause analysis model, um, that is honest to goodness AI, and there's machine learning in different parts of the product. But there's also, as I mentioned, more simple and practical things like lookup tables and 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 so forth. So predictive analytics and forecasting and so forth. So AI is one tool, but sometimes it's too heavyweight for some things, and so we were looking for the best tool for the job, and a lot of times it's AI, but not always.
Right. Now, the next question is a two-parter, and this kind of is the area that I'm personally most interested in. So I'm happy that we have two individuals asked a very similar question, um, which is, applications are changing dramatically, and as you said at the beginning, we're talking about very data-centric applications, but also applications are moving to being cloud native and more and more to the public cloud. So how does the first part of the question is how does data ops change in cloud only, cloud native, big data type applications?
So, well, of course, the data ops itself is a broad term, so uh, it may include things like data lifecycle management and storage management and so forth. So that is fundamentally different in the cloud versus on-prem. But the way Spark and Hadoop and the big data stack runs is very, very similar. So we do collect information about the underlying infrastructure and the containers and the VMs and so forth. So in a sense, the Unravel product works exactly the same. It will look exactly the same. We do have some cloud-specific technology. In particular, we provide migration intelligence so that people that are migrating from on-prem environments, from physical hardware environments to virtual environment in the cloud and Amazon and Microsoft Azure and Google Cloud platforms. So we provide a lot of cloud-specific technology, but most of running data applications behave similarly, if not identically, in those two environments. The thing that Unravel needs to keep an eye on, or that Unravel helps people keep an eye on, is that you don't get one-to-one performance. If you did what we call a lift and shift, I had 80 nodes of physical infrastructure on my Hadoop and Spark cluster in my data center. I wanted to move that to 80 nodes of in AWS or in Azure. You don't exactly get the same performance characteristics, even if you have chosen what you think are the right instance types and sizes. But that really all that means is that you use Unravel uh, to do data collection on the applications running in the cloud, and then can advise you, recommend, and provide insights on what you have to do to get the same service levels in the cloud that you were getting in on-prem environments. So very similar, but um, but there are some performance characteristics that differ in the cloud environment. Versus when you have your hands on the disks and on the servers in your own data center.
Great. There's a second half of that question I want to ask, and then two more questions I want to get through. If we don't answer your question, the folks at Unravel will get back to you with answers to those. But after the second half of that question and the next two, we're going to go ahead and do the giveaway of the Amazon gift cards. So the extension of that question is not only cloud, but also modern application architectures like microservices. What are the considerations in the microservices world with regard to data ops?
So microservices is really kind of an application architecture decision to make. Am I going to do um, lots of microservices and construct them into micro data pipelines, or have them be a processing fabric? So it's a tough question to answer without a little bit more detail about what you mean and how microservices are being used. But the underlying DataOps challenge is pretty much the same, as in what resources are being used, are they right-sized for those services, are they scheduled correctly? Um, so I think I think that's really kind of, I know I'm hedging a little bit on this answer because it's a little bit of a it depends sort of answer, um, but Unravel would treat that, for instance, really as, as applications, or stages, depending on how they're implemented. If this is a multi-stage um, Spark, if this is services that are strung together in a Spark data pipeline, then we can view it as a workflow or as individual atomic applications. So it kind of depends on what the application architect really wants to see, and how they want that to behave, I think. Um, so a little bit of a hedge on my answer, but that's what I
Right.
think.
And I imagine, it has to do with things like persistent storage, where the actual data lies in a microservices application, and a lot of other elements. But a key aspect to, I think, what you presented is just the fact that you need visibility across your application. So
Yes, and the auto tuning, and I didn't describe the feature. It's called sessions, but Unravel has a kind of a very interesting feature called sessions, and that is you create. It's an auto tuning workflow where you run your application multiple times, and Unravel gains better and better intelligence as you use this session feature and run the application with multiple runs. You can look at I showed you the little line graphs, but those could be done on microservices as well as as well as full blown MapReduce or Hive or Spark applications. So we do provide some intelligence that would be relevant to a microservices approach to app dev.
great. And the next question is around kind of getting started, and maybe it's about best practices. So the question is, if you're starting from scratch, what are some of the things that the design patterns or considerations you should think about, and also relates to, how do you think about the tooling that you want to bring in for data ops?
Well, the notion of getting started, most enterprises are already started, whether they call it data ops or not. There are people doing these jobs. So, uh, so there is an organizational component to this. Is your IT organized so that it has executive level sponsorship and participation? So that could be a chief data officer or chief analytics officer, whoever that is, or it could be someone on the analytics team that is just designated, or it could be an application or a data architect or an enterprise architect. So part of it, as I mentioned before in the Swiss cheese incident, that you have to have organizational, your organization, basically decide that you are doing data ops, and do some research into which of the data ops disciplines or sub-disciplines, I should say, are the most relevant to your data program, your big data program, and make sure that your organization is in place and that there is a strong lead in all of the, in all the positions that matter, and that you architect, that you have application and infrastructure architects that know what they're doing. So right now in the data world, the big data world, there are there are lots of different tools and consoles and stuff like that, and so a lot of people are already contending with this. What I do recommend is that once that you are, that you feel that you are doing this data ops function, um, that you should give Unravel a look. If you have any kind of clusters, you can always look at the logs, and you can always, you can throw things into a log analytics tool, but to get the level of comprehensiveness and clarity, it'd be worth giving Unravel a look for that reason.
Yeah, sorry about that, George. I had a little technical blip.
No worries. I'm still here.
but I'm back. And I don't know if you answered this question about also how Unravel and DataOps fits in the modern delivery chain and CI/CD.
No, didn't get that question. I'm going to actually punt on that one. I don't have a good answer for that.
Okay, no problem. So I think that this was a great conversation, and I encourage everybody to take this recording and share it with your peers, because there's a lot of good data here, and things to consider that I think I found personally when I've had conversation with organizations that, like you said before, organizations are already doing this, but they don't call it data ops. And there's a lot of special elements to consider in data ops and how it fits in modern applications. So with that,
one second, Chris. Let me unpunt on that, because I didn't grok the question until I saw it on the screen. So,
sure.
So I showed you during the demo that Unravel tool has really two main kind of dimensions: the ops dimension and the apps dimension. For developers, so one of our biggest customers, who is a bank in Europe, they are putting Unravel consoles on every big data developer's desktop. That is because we provide. I didn't show you, but we actually can map what's going on with errors and so forth and alerts. Map it right directly to the Spark source code. So there's a lot of intelligence that an app developer can get from Unravel. So there is definitely an application for continuous development, continuous integration environments that is going on. I don't have a lot of detail on that, but I do know that a number of our customers are putting in the hands of development and integration teams for that reason. Just so for the visibility, so that they can see how their applications interact, because it's the other hallmark of these distributed environments, that you can get yourself into big trouble, what we call rogue applications, if someone way over allocates on memory or on cluster or so forth. So it's definitely helpful for integrators and developers to see how their Hive, Spark, or Impala or Tez applications are interacting, how they're operating, and we can give you great detail on their configuration and so forth. So I hope that answers that question. It doesn't maybe totally, but there it is.
Yeah, well, I always tell people that you don't have a modern delivery chain until you have visibility. So that is the central part to be able to build on. Well, George, thank you for your time. I'm going to quickly announce the giveaways, today's winners. So the first winner of the Amazon gift card is Elizabeth A.
Yay.
The next winner is Raywan K.
Yay.
And then finally, Jeremy E. Congratulations for winning the $50 Amazon gift card, and you'll be receiving a notice in email on how to obtain that. And everybody, thank you for joining today's webinar. George, thank you. It's recorded, so make sure you share this with your peers once you get the link. And I think this was great data, so thanks for joining us today.
Thanks, everybody.